Some galaxies look perfectly serene. But others? Well, others look like they've been in a cosmic brawl. Today, we're investigating one of those, the beautiful but very strange Messier 99. It's also called the St. Catherine's Wheel, and we're about to figure out what could possibly have given this gorgeous pinwheel galaxy such a lopsided, beat-up look.
Okay, just look at this. On the left, you've got your picture-perfect spiral galaxy. It's neat, it's symmetrical, it's exactly what you'd expect. And then, on the right, there's our galaxy, Messier 99. You see the difference right away, don't you? One of its spiral arms is way more stretched out and defined than the others, almost like it's been pulled. It's stunning, for sure, but it is definitely not your average spiral galaxy.
So that's it. That's the big question for today. What in the cosmos could be strong enough to knock a galaxy with hundreds of billions of stars completely off kilter like this? To get to the bottom of it, we're going to have to play cosmic detective and start gathering some clues.
So first, a few basic facts. M99 is way out there, about 52 million light-years away from us. But the really critical piece of information here is its neighborhood, the Virgo cluster. Now, this isn't some quiet galactic suburb, not at all. The Virgo cluster is this bustling, incredibly dense city of thousands of galaxies, all zipping past each other at insane speeds. It's a chaotic place, a place where cosmic fender benders are bound to happen.
All right. Our first step in this investigation is to check out how the galaxy is actually moving. I mean, if something big and powerful smacked into M99, you'd expect to see some evidence in the motion of its stars and gas, right? We need to see if it's wobbling or if its spin is all messed up.
So how do we do that? Well, astronomers have this really cool tool called harmonic analysis. Think of it like this. You hear a giant orchestra playing a complex piece of music. Harmonic analysis is what lets you listen in and pick out the sound of just the violins, or just the trumpets. We can use that same idea to break down the galaxy's jumbled rotation into its basic parts and see which notes are out of tune. And what exactly are we tracking? We're zooming in on what's called H-alpha emission. That's just a very specific red glow coming from hydrogen gas. This gas is basically the fuel for making new stars, and it does a beautiful job of tracing out the spiral arms. So if we can track how this gas is moving, we can figure out how the whole galaxy is moving. And here's what that looks like. This is its velocity map. Thanks to the Doppler effect, we can see which parts are moving towards us, that's the blue stuff, and which parts are moving away, that's the red. Now, a perfectly spinning galaxy would have this nice, smooth, symmetrical pattern. But M99's map, it's anything but smooth. It's all distorted and asymmetrical, a clear sign of a very messy rotation. So, there you have it. The harmonic analysis totally confirms our suspicions. The math is solid on this one. M99 is, in astronomer speak, kinematically perturbed. Basically, its motion has been seriously disturbed by some outside force. So, case closed on part 1. M99 has definitely been in a fight. But who is the bully? To find our culprit, we have to look deeper, beyond the visible light, beyond even the motion of the gas. We need to look at the invisible forces holding this whole thing together. Specifically, the galaxy's magnetic field. Think of it as the galaxy's hidden skeleton, and it might just remember what happened.
Now, before we look at the data, you've got to remember one fundamental rule of physics. As Donnelly Scott said, magnetic fields are created by electric currents, period. They're not just some random force out there. They are the direct evidence of massive electric currents flowing through the plasma of the galaxy. So when we map out a magnetic field, what we're really doing is tracing these giant pathways of cosmic electricity. And this is what that map looks like. Using radio telescopes, we can see the magnetic field of Messier 99. Those little lines you see show the direction of the magnetic field. For the most part, they seem to follow the spiral arms, which makes sense. But look down there. In the southern part of the galaxy, something really strange is going on.
This map makes it even clearer. This shows the polarized radiolite, which is just a fancy way of highlighting where the magnetic field is the most organized and strongest. And boom, right there in the south, you see it, this bright, concentrated feature that scientists call a polarized ridge. This is an area where the magnetic field is unusually powerful and orderly. This is a massive clue.
And here is where it gets super weird. You would normally expect the strongest magnetic fields to be right in the middle of the spiral arms, where all the gas is getting squished together. But this magnetic ridge is offset. It's not in the arm, it's on the outer edge of it. It's almost as if the magnetic field has been literally pushed or pulled away from the gas it's supposed to be attached to.
And this right here, this graph is our smoking gun. This is a measurement taken right across that southern arm. See the dotted line? That's the peak of the glowing hydrogen gas. That's the visible spiral arm. Now look at the solid line. That's the peak of the magnetic ridge. See that gap? They do not line up. The peak of the magnetic field is clearly shifted away from the peak of the gas. This is undeniable proof that some external force has sheared the magnetic field away from the rest of the arm.
Okay, so let's recap. We have a galaxy whose motion is all messed up, and we have a magnetic field that's been displaced. Both clues point to an outside job. It's time to line up the suspects and figure out who's responsible for this cosmic harassment.
When you live in a crowded place like the Virgo cluster, there are two main troublemakers. First, tidal forces. That's what happens when another huge galaxy flies by really close, and its gravity literally stretches and pulls on M99. Suspect number 2 is something called ram pressure stripping. You see, the space between galaxies isn't empty, and when M99 plows through that hot gas at incredible speeds, it creates a headwind so strong it can literally blow the galaxy's own gas right out of it. So when you put those two things together, the constant gravitational tug-of-war from other galaxies and that relentless headwind from the cluster gas, you get a phenomenon that astronomers have the perfect name for: galaxy harassment. It's a process that can completely change a galaxy's shape, its motion, and yep, its magnetic field. All the evidence points to one conclusion: M99 is probably a new kid on the block. It's just arrived at the Virgo cluster party, and it's diving into this chaotic environment for the first time. It's like trying to walk through a packed subway station during rush hour. You're going to get jostled and pushed around by the crowd. And that lopsided shape? That's the result. You know, solving the case of Messier 99 isn't just about one galaxy. It's actually a fantastic snapshot of how all galaxies evolve. It shows us that they aren't these calm, isolated islands of stars. They're dynamic, living things that are constantly being shaped by their often violent surroundings. And we can even put a timestamp on the main incident. Based on computer models, astronomers think the big gravitational encounter that really started this whole transformation happened about 280 million years ago. To put that in perspective, that's right around the time the very first reptiles were starting to walk around on Earth. So what are the big takeaways here? First, galaxies are always changing, always evolving. They are not static. Second, a galaxy's neighborhood, its environment, is absolutely crucial in deciding what it becomes. And finally, sometimes the biggest clues to a galaxy's violent past are hidden in plain sight, in invisible forces like the huge electric currents that create its magnetic skeleton.
The story of Messier 99 is really a story about how galaxies are forged in the fires of cosmic collisions. It's happening all over the universe. And that just leaves one final thought. Our own galaxy, the Milky Way, is on a collision course with our neighbor, Andromeda. They're set to merge in about 4.5 billion years. So what do you think our own galaxy will look like after its own episode of cosmic harassment?